Hello everyone. Our lesson today is lesson 3, multiplying matrices. We said before how to add two matrices, and we have condition. They must have the same order. Okay, what about the condition of multiplying matrices? If we have two matrices like A equals 3, 0, 1, 2, 3, 5. Okay. And another matrix B equals 2, negative 1, 0, 4, 5, 1. Okay. Here, the first matrix, its order is 2 rows, 3 columns. So 2 multiplied by 3. The second matrix is 3 rows multiplied by 2 columns. Okay, so here we have equals 3 and 3. Here in 3 is the number of columns in the first matrix equal the number of rows in the second matrix. So the condition of multiplying two matrices is the number of columns of the first matrix must be equal the number of rows of the second matrix. Okay, and the result AB is a matrix. Its order is 2 times 2. Okay, our condition in multiplying matrix is the number of columns of the first matrix equal the number of rows of the second matrix. Okay, let's take an example. Here, if A equals 3, 0, negative 1, 2, 1, 5, B 3, 2, 1, negative 1, 0, 4. We want to get A multiplied by B. First check. Here we have the order is 2 multiplied by 3. And here the order is 3 multiplied by 2. Here we have 3 equals 3. Okay, the number of columns in the first equal the number of rows of the second. Okay, so the result of A multiplied by B is a matrix of order 2 times 2. Matrix contains 2 rows and 2 columns. Okay, let's get A times B. Here A multiplied by B. Write the two matrices. A, which is 3, 0, negative 1. Here 2, 1, 5. B 3, 2, 1, negative 1, 0, 4. Okay, to get the multiplication of two matrices, first write row here in the first matrix and column in the second matrix. First write row in the first matrix and column in the second matrix and write a big bracket. Okay, how to multiply? First we have the first row here 3, 0, negative 1 multiplied by the first column and the second column. But be careful. Here we have the first element times first, second times second, third times third, and between them addition. How? Here 3 times 3, 9, plus 0 times 1, 0, plus negative 1 times 0, 0. Okay, we finished the first column. What about the second column? Also 3 times 2 equals 6, plus 0 times negative 1, 0, plus negative 1 times 4, negative 4. Here we finished the first column. What about the second? We finished the first row. What about the second row? Similar. 2 multiplied by 3, it will be 6, plus 1 times 1 equals 1, plus 5 times 0 equals 0. The second column. 2 times 2, 4, plus 1 times negative 1, negative 1, plus 5 times 4, 20. And get the results. So here, 9 plus 0 plus 0, 9. 6 plus 0, 6 minus 4, 2. 6 plus 1, 7. 4 minus 1, 3, plus 20, 23. So A times B, which is AB, is a matrix, as we said, of order 2 times 2. Okay, what about B times A? B multiplied by A. Okay, B is 3, 2, 1, negative 1, 0, 4. And A, 3, 0, negative 1, 2, 1, 5. First, check. Here we have 3 times 2, and here we have 2 times 3. As we said here, the number of columns of the first equal the number of rows of the second. Okay, so open big bracket. Here, write row in the first matrix and column in the second matrix. 3 times 3 equals 9, plus 2 times 2, 4. The second column, 3 times 0, 0, plus 2 times 1, 2. Third column, 3 times negative 1, negative 3, plus 2 times 5, 10. We finished the first row. What about the second row? Here, 1 times 3, 3, plus negative 1 times 2, negative 2. 1 times negative 1, 1 times 0, 0, plus negative 1 times 1, negative 1. 1 times negative 1, negative 1, plus negative 1 times 5, negative 5. What about the third row? 0 times 3 equals 0, plus 4 times 3, 4 times 2 equals 8. 0 times 0 equals 0, plus 4 times 1 equals 4. The third column, 0 times negative 1, 0, plus 4 times 5, 20. Get the results. 9 plus 4, 13. 2, 7. Here 1, negative 1, negative 6. 8, 4, 20. What did you notice here? Here is a matrix consists of 3 times 3, as we said. Okay, what about the results of AB? Is a matrix, its order is 2 times 2. BA is a matrix, its order is 3 times 3. So here we have A times B doesn't equal B times A. Okay? We have some properties. The properties of multiplying matrices. First, as we said, not commutative. If we have two matrices like AB, A times B not equal B times A. Okay. Number 2, associative property. If we have three matrices A, B, C, AB times C equals if we have A and B times C. Okay. The multiplicative identity. We said before, identity I, the unit matrix. What's the meaning of unit matrix? Its diagonal is 1. Okay? So here we have A times I equals I times A equals I. For example, we have here matrix 2, 3, negative 1, 5 multiplied by the unit matrix. As we said, its diagonal here is 1. Okay. To get the results, as we said here, the first matrix, right row, and the second matrix, right column. Okay. Open big bracket. Here, 2 times 1 equals 2, plus 3 times 0, 0. Second column, 2 times 0, 0, plus 3 times 1, 3. We finished the first row. What about second row? Negative 1 times 1, negative 1, plus negative 1 times 0, 0. Negative 1 times 0, 0. 5 times 1, plus 5. So the result will be 2, 3, negative 1, 5. What did you notice? Here the same matrix. So any matrix times the unit matrix, which is I, is the same matrix. Okay? Finally, distributing multiplication of matrix on addition property. If we have here A, B plus C equals distributive, it means A times B plus A times C. And also if C here, so AC plus BC. Let's take some examples. Number 1, if A is 2, 1, 3, negative 1, prove that A power 2 minus A minus 5I equals 0. What is A power 2? 4, 1, 9, 1? No. A power 2 here, it means A times A. Okay? Here, A power 2 equals A multiplied by A. Okay? A is a matrix. So here A is 2, 1, 3, negative 1 multiplied by 2, 1, 3, negative 1. As we said, to multiply, check the number of column of the first matrix equal the number of row of the second matrix. So here 2 times 2, and here also 2 times 2. Here number of 2 equal 2. Okay, get the results. So open a big bracket. Write in the first matrix row, second matrix column. Okay, so here 2 times 2, 4, plus 1 times 3 equals 3. Second column, 2 times 1, 2, plus 1 times negative 1, negative 1. Okay, write second row. Here, 3 times 2 equals 6, plus negative 1 times 3, negative 3. Second column, 3 times 1, 3, plus negative 1 times negative 1 equals 1. Get the results. 4 plus 3 equals 7. Here 1, 6 minus 3, 3, and 4. So A power 2 equals 7, 1, 3, 4. Okay. We get A power 2 minus A is a matrix, which is 2, 1, 3, negative 1, minus 5I. What's the meaning of I? As we said, I is the unit matrix, which is a matrix. Its main diagonal is 1. Okay. Equals 0. 0 here is 0 matrix. Okay. So we want to prove that A power 2 minus A minus 5I equals 0. So first, get the left hand side. So the left hand side here, which is A power 2 minus A minus 5I. Okay, substitution. A power 2, as we said, A power 2, 7, 1, 3, 4. Minus A, which is 2, 1, 3, negative 1. Minus 5I, 5 multiplied by I. As we said here, I is the unit matrix. Okay, unit matrix consists of the order of it 2 times 2 or 3 times 2 or 2 times 3 or what? Here we have two matrices, 2 times 2. So of course here the unit matrix is also 2 times 2. So its diagonal is 1 and the other is 0. Okay. How to solve this? First, 5 multiplied by this matrix. So multiply every element by 5. 1 times 5, 0 times 5, 0 times 5, 1 times 5. Okay, so write the first matrix as it is. 7, 1, 3, 4, minus 2, 1, 3, negative 1, minus here 5 times 1 as we said 5, here 5 times 0 0, 5 times 0 0, 5 times 1 5. Okay, as we said in the previous lesson, minus or subtraction the corresponding elements. How? 5 minus 2, sorry, 7 minus 2, 5 minus 5 equals 0. 1 minus 1, 0 minus 0, 0. 3 minus 3, 0 minus 0, 0. 4 minus negative 1, it will be 4 plus 1. 5 minus 5, 0. So here we have the 0 matrix, which is denoted by O. So the left hand side here equals the right hand side, which is O. Okay, let's take another example. Here, if 2, 3, 4, 5, here what's the operation between the two matrices? Is multiplication. Okay. X 7, 3y equals 7, 8, 11, 18. Find the value of x and y. Okay, how to solve this problem? First, simplify the multiplication. As we said here, multiplication, write in the first matrix row and the second matrix column. Okay, so open a big bracket. Here, 2 times x, 2x, plus 3 times 3 equals 9. What about the second column? 2 times 7, 14, plus 3 times y, 3y. We finish the first row, the second row. Okay, 4 times x, 4x, plus 5 times 3, 15. 4 times 7, 28. Plus 5 times y, 5y. Okay, all of these equal the matrix 7, 8, 11, 18. We said in lesson 1, two matrices are equal, so the corresponding elements are equal. How? Here we have 2x plus 9 equals 7. So we get here 2x plus 9 equals 7. It's an equation. Move 9 in the other by negative. So we get 2x equal 7 minus 9, which is negative 2. So 2x equal negative 2. Move 2 in the other by divided. X equal negative 2 divided 2. So we have x equal negative 1. Okay. And also here 14 plus 3y equals 8. 14 plus 3y equals 8. Move 14 in the other by negative. So 3y equals 8 minus 14. We get 3y equals negative 6. Move 3 in the other by divided 3. We get y equal negative 6 divided 3. It means y equals negative 2. Okay. To check substitution here, move x and write negative 1. 4 multiplied by negative 1 plus 15, it will be 11. And substitution by y, negative 2, 28 plus 5 times negative 2, it will be 18. Okay? Okay, let's take An example, if A is 2, negative 1, 4, 3, 5, 7, B is 6, 1, negative 3, 9, 2, negative 8. Check that, it means prove that, okay? AB all transpose equal B transpose A transpose. Okay, first get the left hand side, which is AB transpose. First get AB. Okay, write A 2, negative 1, 4, 3, 5, 7. And B 6, 1, negative 3, 9, 2, negative 8. First check to multiply. Here we have 2 times 3, and here 3 times 2. 3 equal to 3. So the result will be matrix consist of 2 rows and 2 columns. Okay? Open and big bracket, and don't forget to write the first matrix, right row, and second matrix, right columns. Okay, here 2 times 6 equals 12, plus negative 1 times negative 3, 3, plus 4 times 2, 8. Okay, the second column, 2 times 1, 2, plus negative 1 times 9, negative 9, plus 4 times negative 8, negative 32. We finished the first row. What about the second row? 3 times 6, 18, plus 5 times negative 3, negative 15, plus 7 times 2, 14. The second column, 3 times 1, 3, plus 5 times 9, 45, plus 5 times negative 8, negative 56. Get the results. Here 12 plus 3 plus 8, 23, negative 39, here 17, and finally negative 8. Okay, here is AB. We want to get AB transpose. What's the meaning of transpose? Make the column row and row is column. Equals. Here the first row is the first column, 23, negative 39, and 17, negative 8. Okay, so this is the left hand side. Okay, what about the right hand side, which is B transpose A transpose? So B transpose A transpose. Okay, B transpose, here we have B is 6, 1, negative 3, 9, 2, negative 8. So B will be 6, negative 3, 2, 1, 9, negative 8. Okay, A transpose will be 2, 3, negative 1, 5, 4, 7. To multiply, check the order. Here will be 2 times 3, and here 3 times 2. Okay, open a big bracket. As we said, the first matrix right row, second matrix right column. So here we have 6 times 2, 12, plus negative 3 times negative 1, 3, plus 2 times 4, 8. Okay, second column, 6 times 3, 18, plus negative 3 times 5, negative 15, plus 2 times 7, 14. We finished the first row. The second row, 1 times 2, 2, plus 9 times negative 1, negative 9, plus negative 8 times 4, negative 32. The second column, 1 times 3, 3, plus 9 times 5, 45, plus negative 8 times 7, negative 56. And get the results. We have here the results 23, 17, negative 39, and negative 8. From 1 to 2, we get A, B transpose equal B transpose A transpose. And from here we have a remark which is AB transpose equal exchange, so start from the second matrix, B transpose A transpose. And remember, in addition, A plus B transpose equal the first transpose plus the second transpose. But in multiplication, start from the second. Okay? Thank you.